Let's take a look at how to make some simple graphs on Microsoft Excel. You can see I have a horizontal axis series established. I'm going to put time on the horizontal axis. I'm going to chart displacement versus time. So I have two series for displacement. And just a little bit of a look at some of the Excel overall features. You can see my displacement title here doesn't fit. So there's two ways I can approach that. I can hover between the B and C columns until I get the icon that looks like a slider, and I can click on it and I can just drag the width to whatever I want. Or I can make that column width fit the widest element by hovering over and double clicking on that joint between the two columns. You can also do that over here. It's too wide. I can double click there and shorten it up so that time just fits. And then C, you see displacement 2, the title is good, but that's only because there's nothing in cell D1. So I can also double click on that and make that column wide enough. But now I've got all my data. And this is pretty convenient because I have a measurement for displacement at each time. So I don't have to worry about any kind of gaps in my series. To create the simplest graph, I'm going to do a scatter graph. I'm going to highlight all of my data. I'm going to come up to Insert, and over here on Charts, hover over the Scatter chart, pull it down, and I'm going to choose Scatter with just markers. I'm not going to draw any lines at this point. Now I will tell you that my blue Series 1 points are points that would be plotted if I were to graph the line y equals 2x. So there is a straight line that will connect all of those points. However, if you look at my Series 2 up here, the orange dots, these approximate the line y equals 2x, but they're not exactly on it. So there is no straight line, and I'll show you. If we were to come up and change this chart type to have straight lines drawn, you would see that the orange series, the lines do not go in a straight line from the first point to the last point. So that's not the graph of a straight line. But we can have Excel find us a line of best fit, or the best approximation to a straight line that would contain all of those. So we'll go back up here, we'll select the chart, we'll make sure we're on design, and we'll change the chart type back to just scatter points. We can have Excel draw us the line that would approximate it. So the way to do that is you single click on the chart, you come up here to Add Chart Element, and you choose Trend Line. Now these appear to be linear graphs, so we're going to choose a linear line, and we're going to have it draw a linear line for Series 1. And sure enough, it approximates the line of best fit, which in this case is the line y equals 2x. And I know that by clicking on that line, and you can see the little grip over here tells me that I have it selected. Then over here under Format Trend Line, I can click on Chart, and I can actually have it display the equation on the chart. And sure enough, there it is, y equals 2x. It's pretty handy if you want to go to additional features of graphing by knowing what the equation is for that line of best fit. But let's not show that for now. We'll come back here and we'll click on the line, come back over to the chart options, and not show the equation. We also want to show a line of best fit for the orange series, Series 2. And we do that by selecting the chart, coming up to Add Chart Element, going down the trend line, selecting linear now for Series 2, and there is our line of best fit for that data. And if I select that line and then ask them up here under trend line options to show the equation on the chart, you'll see that the equation for that line is y equals 1.9576x plus 0.0109. Pretty exact, but not super helpful. Other than this, because it's y equals mx plus b, this tells us the slope of the line that fit best. And we've talked in class about what it means to take the displacement versus time and take the slope. That means we're doing change in displacement over time, which is velocity. So this tells us that this is a constant velocity line of data with a constant velocity of 1.96, and if it was meters over here and seconds on here, it would be meters per second. So this is helpful to start to find some additional information about our movement. But again, let's not show the equation at this point. So I select the line again, come back over to trend line options, and not display the equation on the chart. Now let's say we don't have a displacement for every time in each series. So here at time 3, displacement 2 doesn't have a value, so only the first series has a value. At time 4, only the second series has a value, and so on. So this is a place where having Excel draw a chart with a line from the start is really going to fall apart, because it tends to skip line segments where there aren't any data recording. So let's now delete by selecting and then choosing delete each of these lines. Let's change the chart type. I want you to see what it looks like. Go up to Design, change Chart Type, and let's put a smooth curve in, for example. And you see that because there are data gaps, the lines have gaps themselves. So this is a great example of why we don't have them draw the line up front, that we go in and we put in a trend line. So if we take this back to a scatter graph with just markers, and then we come up here and add trend lines for series 1, it now draws a straight line. And believe it or not, it still is going to be y equals 2x, because even though there are gaps, all of these points fall on that line. Now if I were to show the trend line for series 2, let's see what leaving out some points does to the equation for that line. Doesn't do much to it, but you can see it's a little different. So the line of best fit has adjusted because there are fewer points to use to approximate that line. And that's why we wanted to use as many data points as possible, because we get a better approximation with more data points. But for now, let's delete that. And let's actually create a new tab and look at what it looks like when we have motion that is not constant velocity but now has a non-zero acceleration to it. Now I have 2 more series of displacement points for given times, and this in column B is actually the displacements that would work if we were graphing y equals x squared. That would mean that for x being our time, the displacement is the square of each time, a parabola. This series over here in column C, displacement 2, is a little off. So I took each point to be about the square of the time, but a little off either high or low what it should be. So let's create a chart that shows these 2 series together and see how creating a best fit curve for these would go. So let's first go up to Insert and create a chart with smooth curves. And you see that suddenly, because we're off, and which point did oh, look at that, 0.9, I really screwed up. Let's say that's going to be 48 instead of 28. It's a little better, but again, it's not a smooth curve. It has some bumps and transitions to it. Whereas the blue curve is a smooth one because it truly is y equals x squared. Let's go up here and in Design, after we click our chart, we'll change chart type to just be the markers. And let's add some trend lines. So we will select the chart, up on the Design tab, click Add Chart Element and Trend Line. And let's add a linear line of best fit for Series 1. And you'll see that, okay, they're able to create a line of best fit because there's an equation for it, and you can pretty much make any line look like it fits. But we can tell that these blue dots, they don't appear to be a linear group of data. So let's, instead of using a linear line, we'll select it. And instead of linear, why don't we choose polynomial? Because we know that this is a polynomial graph of order 2, but really it's a monomial. Doesn't matter. But the fact that we now see it as a parabola means that, well, this is probably the best line or curve to use for that series. And it appears that the second series is the same, so we'll come up here to Add Chart Element. We'll come down to Trend Line. We're going to pick on more trend line choices. Sorry, we have to add a trend line first. So let's add a trend line. We'll just pick linear for Series 2. We know that's not what we want, so we select it, come over here, we'll choose polynomial, second power for our variable. And sure enough, look at that. In this case, even though the points are off of the curve, it looks very close to be y equals x squared. And let's just show the equation on the chart. And sure enough, 1.05x squared, that's our x squared term, that's pretty close to 1, because the other one would be y equals 1x squared. So this is a pretty good approximation. There's also a y offset here over with the constant, so it doesn't exactly go to 0, but this is pretty close. So that's a good approximation. And that's what I think you should use if you see that your data looks like it is not a linear data set. You should probably use the polynomial type. And again, if you have some points over here where you don't have a displacement measured for each time, it will still create an approximate fit for you. It still looks like a parabola even though we've removed several of the displacement measurements, but that's a good way to get two different series graphed on the same chart even if you don't have a data point for every time. So if you have a time for 2.2 seconds for one but 2.7 seconds for the other, put in both times so your x-axis is consistent, but then you'll see that you have to just fill in the displacement data for the time that you have. Good luck.